This is our today's topic, functions in R. So you are going to use R software to create functions which do different tasks. Function is basically written to do a certain task, and you can call the function in any of the places that you want to, right? For example, mean is a function which R Studio has inbuilt. Sum is again another function. So they are inbuilt functions. Inbuilt functions means the base package has already defined you the functions, so it's just a matter of calling them and using them, right? So today we are going to discuss how to create your own functions, user-defined functions. Own functions, you call it user-defined functions. So the basic structure of a function is it should have a name. The name should, it's not a must, but it's a good practice to use a name which indicates the functionality of the particular function. That is, if you are going to find an average of a couple of numbers, it is good to make use of the word average somewhere here in the function. You can even give your name here, doesn't matter. Function can take any name, but it's a good practice to use meaningful names for functions so that in programming, some third party can understand your algorithms, and it is very convenient to reuse what you have done. So anyway, it should have a function name, and the function name is assigned by the function. So you have to write this keyword function. Within brackets, you can either leave it as it is, or you can give arguments. You can pass arguments, comma separatedly. If it is just one argument, you can give one. If you have a couple of arguments, comma separatedly, you can give. And you open a curly bracket, you do something here. And you close the curly bracket. This is the basic format of function. And when you are calling the function, so let's say you have two arguments here. Let's say you have two arguments here. In that case, whenever you are calling this function, you can call it by the name itself, whatever the name that you have given, right? And pass your arguments here. A value to X and a value to Y. You can give 1 and 2, or it's not simply now, it doesn't have to be simply numbers, it can be words, strings, vectors, anything, right? This is basically how you call a function. So this is not rocket science for you, right? So mean is a function in R. How do you call that function? Mean, within brackets, you give the specific values where you want to find the mean. So if X is 1, 2, 3, how do you give? If you want to find the mean of this vector, you give X here, or you give this one. So mean is a function. This is how we call the function. You write the function name, right? And you pass the arguments where necessary. Some functions don't have arguments. Most of the functions have arguments. You can ask if there's any questions. When we start doing this, you will get used to this. Students who have done computer science, they know this already. But other students, now you should be able to handle this. Okay, so let us start writing a small function as a startup for today. You can try your own function. So we open up our studio and I open up a new session. For my convenience, I did some functions. So don't look at this. This is my script. I'm sharing only this with you. So if I want to write a function to add two numbers and display the results, what will be my function? So I can give a name to that function. So I don't like giving keywords. So I'm defining my own wording to name the function. So add num, I'll give a name, something like that, and function. So to add two numbers, we should give two numbers to the system, right? It's not always that, like if you are going to add the same number, giving it just one time is enough. But basically this function is written in general to add two numbers. When you are, it's just like a calculator. When you input two numbers and press the plus sign, it gives you out the summation. So just like that, you can give any name here, A, B, or X, Y, or any letter there, or even any word, first number, second number. You can choose that. Even when you are writing the variables, it is way better to write like this, so it is very understandable. It's very easy, right? But when it comes to the exam, if you require to write this by hand, it's not really a wise decision to use lengthy names because it takes a lot of time. So keep it short. But my advice is to make it understandable by a third party. Just to give numbers this way is fine, right? The functionality really happens. So you have to decide on that. So I open and close the bracket and press enter. What did I do? When you go here with the shift, when you open the curly bracket, it automatically gives you the closing bracket, and then press enter. So here it formats well, right? It formats well. Whenever you open a bracket, close it. Close it, and that is a good practice. Otherwise, you will miss brackets, right? So if even a single comma or a single bracket is missing, your entire coding would give errors. So it's really hard to find where the error is if you didn't format this properly, if you didn't indent this properly. So indentation helps you and me, both the parties, even when marking your answers and even when finding your mistakes. Right? It's very important when if a code doesn't run properly, if it is nicely formatted, you can easily identify where you have gone wrong. So we can just print this plus this, but it is a good practice again to assign it to another variable. So let's say tot. Just give whatever the name you like. Either you can put equal sign or this sign. Both are the same in R. You can use any sign. So what will be the total summation of these two numbers? So that is whatever the number you give here when you call the function, that one plus the next number. So you assigned it to this, and our question asked us to display the result. That means to show. Display means to print. Okay. You can simply press enter and type the word print. What do you want to print? The addition of these two numbers. So you assigned it to a new variable called tot. So you are going to print out tot. Now this is your function. You are done with it, right? So let's run. You always have to run the function first. Control enter. So it is now R knows, okay, add num is a function which adds two numbers. Now R knows it. Now we have to check whenever we write a function, no matter how simple it is very important to check, because we have to handle things for different scenarios. When you come to the next couple of parts, you will realize what I'm talking about. Okay, so I check for different types of values. So I am going to add zeros together. I'm going to add negatives and positives in mix. I'm going to add two positive numbers, add negative numbers, and see whether this particular function is working properly. So before giving out a function to use to the end user, it is your duty, it is the programmer's duty to check whether the function works properly. Function is a thing that performs some task. Okay, so I want to add 4 and 5. So I'm going to call this function add. Now R knows this function. Earlier it didn't, because this is a user-defined function. I defined it myself. Now, just because I compiled the code, now R knows this, right? And for the, what is the first number that you want to add? Let's say 4 and 5. 4. So to the place of the second number, I give 5 and press Control Enter. You should get 9 as the result. Let's see. Yes, I'm getting 9. This is something like mean. Within brackets, you give a couple of numbers. Something like this. You first define your function, then you call the function. You can assign this even to variables, or assign this even to objects. You can assign, right? So we'll handle those later on. Whenever you do a function, it's better checking different combinations. But if this didn't work for negatives, we have to handle that, right? This should work. This is very simple one. So let's add 0 and -5. It gives you -5. So it's correct, right? Likewise, you can try things off. Now, just as a starting point, I'll stop sharing. Okay. I hope you got this to the head. Write this function, write a function to add 3 numbers and display the result. Now I'm going to stop sharing. Write a function to add 3 numbers and display the result. It's easy now. I just want you to get familiar with the syntax. I know that you know to add 3 numbers. That is first number plus second number plus third number, but I want you to get used to the syntax. So that is why I'm telling you that. So as a help, I'll share the whiteboard. So this is basically the format of a function. Now write a function to add 3 numbers and print the result. I'll give you 2 minutes. It's more than enough. Okay, I got 2, 3, 4 answers in the chat room. Yes, they seem to be correct. Okay, nice. X, Y, Z. Okay. Right. Now you all have understood the syntax. Right. There's nothing big in that, but just because this is the very first time. Okay, I'm getting another one. Okay. Right. I got an interesting answer also, which is an innovation. This was one of your colleagues' answer who have used equal sign. I don't know whether he or she used equal sign with or without intention, but still, this is correct. You can use either this sign or this sign, because in R, when you are assigning something, equal mark and this arrow mark is going to be the same. So very good. So you can, yes, use these things. Right. I didn't share the proper one. Okay. I didn't share the screen previously. Somebody had given the answer as this, which is correct. He or she has used equal sign instead of this one, and it works properly. When you run this, it works properly. So good attempt. You can use either the assignment sign or equal sign, doesn't matter. Usually we use the assignment sign, but it's okay. As long as it's working, it's okay. So the next one is this one. Write a function to display the value of this function. So you are not just adding numbers, right? You are writing a function to display the value of this. You give a value and the function should be able to assign the value in this formula and pop out the value of fx. Can you try? Okay, I got one answer in the chat room, which is correct. AS 2018-474, your answer is correct. But please check, this is the one I asked you to do, give a number, input a number and print the result. Try a couple of values and see whether you are getting the desired result. Just because I got one answer in the chat room, I'll do the function for you all. Some of you might be struggling here. Some of you might be getting errors. I'll tell you why. So we can simply, I'll use the same name I used here. First function 1, because I'm going to have some modifications here. F1, I just named the function as that. So function, I should give x here, and so let me call this the result. Result is equal to, if somebody copied and pasted this here, we'll see what's happening. You're getting an error. Why? Unexpected token X. So X's can't be there, letters can't be there within numbers, within operations. So there should be a mathematical operator here. 3x, yes, we write it, write that way in algebra. What is the meaning here? 3 times x. So multiplication in R is given by the asterisk sign. Whenever you give the asterisk sign, it identifies it as the product. So you have to take the product of 3 with the value x and then add 18. Now your function should work. So let me run this. Yes, I'm getting correct answers in the chat room. Very good. So I have to check this now, whether it is working properly. So I'll give 1. It should give 18 plus 3. That is 21. I can give -1 and see whether this is working properly. Yes. 18 minus 3 is 15. I can give 0. Just give different types of numbers and say, don't give positives all the time, or no, don't give negatives all the time. Try different values. Just give decimals also and see. Still it's working. Even if you give it as a fraction, it is working. 1/2 is half. So this is working. And if I want to give a vector of values, something like this. Let's see what is happening, right? So it takes, we have run this. So instead of just a single number, I'm giving a vector of values. Let's see what's happening. I'm getting values. I'm getting the result for each and every x value here, right? So 3 times 1 plus 18 is 21. 3 times 2 plus 18 will give you 24. 3 times 3 plus 18 will give you 27. So even though you give a vector, this particular function works. So that is why we call it a high-level language. If in C or C++ or any low-level language, if you give it like this, the algorithm is very complex. Even to add 2 numbers, you have to adapt arrays. Even here, we have to go for complex manipulations, but the simple stuff, it's very straightforward. So you can give even 1 million numbers here. It assigns the particular value and prints this one. Just because this is just displaying, you are getting the result, right? So we'll try a couple of negatives also. It's working. So just because this is displaying, it works. for the entire vector, so that we can give even a vector here. X is a vector in this case. In this case, X is a vector. In this case, X is just a numeric. It's just a value. Okay, now I'm making use of the control structures, right? You're given a condition. This one. Write the same function, okay, to return the value, particular value, where now X is conditioned. X should be greater than 0. If X is 0, it should not output a value. If X is negative, it should not output a value. Why? Because the range of X is greater than 0. So whenever you give an invalid number here, if the function outputs a value, then there should be something missing in your function. So now create a function, name it as F2. Okay, so this is the first function. This you can name it, give any name for the moment, right? Take it as F2. Same thing, but this condition should be adapted. Try building that function, make use of the syntax of control structures as hint. I'll give you 3 minutes. I got 2 answers, which is not the expected one. No, 2 answers in the sense from the same person. Okay, I suppose it's the last answer. So you have used a for loop, which is not the case here. So for loop is to repeat something. You are using the loop to repeat something, and just get into the correct structure of the for loop. Like it says, for some variable in, you give the range, and the range is to loop between starting value and the end value. Okay, so AS 2018-341, you have to check your code. Next one. Great. AS 2018-474. Your answer is correct. AS 2018-504. Yes, your answer is, your logic is correct, but your function has a careless mistake. It is 3x plus 18, not 3x plus 8. I'm talking to AS 2018-504. So be careful when you're concentrating on the logic. Don't do careless mistakes, right? So anyway, the logic is correct. AS 2018-474. Yes, your answer is correct. Is 2018-481, your answer is correct, and you have checked for a couple of conditions as well. That's good. You have checked for necessary conditions, a positive and a negative. Also, you could have checked for 0, whether it is printing the proper one. Okay, I think you all are approaching answers. Don't panic if you couldn't get it. It's totally fine. The reason behind being not able to get this is not that you don't have logic in your head, nothing like that. The thing is, you have forgotten the syntax, or the forgotten the functionality of loops. forgotten the functionality of control structures. So when you get used to this, this is going to be very easy task. So don't worry if you didn't get this at the first shot. It's okay. So I'm going to name my function as f2. You can give any name. And simply I'm going to have the variable here. I'm going to include this one. Of course, I have to have the same thing here, same logic here, but I have a condition on x. If x is greater than 0, it should print the result. Otherwise, nothing. So I didn't tell you the else statement. So this is going to be an if else one. If x is greater than 0, do this. Else, I didn't tell you to do anything, right? So a couple of y'all have printed some other statements. It's invalid, x should be a positive. Yes, that is the desired one. So just because I didn't clearly mention to what to do if x is less than or equal to 0, both answers are correct, right? What I mean was there was someone who had written like this. If within brackets you give the condition, this value is greater than 0, open and close the bracket, press enter, do this. So I'm going to copy and paste. Someone has done only this. He or she hadn't done the else statement. That is fine, because I didn't tell you what to do if this is not happening, right? So if this is the case, I'll just copy out some stuff from here. I'm going to check x equals 4, x equals -1, and x equals 0 to see whether this is working. So I had run the function first. So if I didn't give an else statement, it doesn't output anything if I give an invalid one. So that is acceptable here, because I didn't tell you what to print if this condition is not satisfied, right? So that way is acceptable. If you want to print out something, if you want to give some output, you can adopt an else statement and say, print something, print this is invalid input, x should be greater than 0, something like that. Right, okay. Now, yeah, so I'll just write, copy and paste your answer as well. I'll just write it. If I had an else statement, okay, it should output invalid input for these two stages. Something like this. Okay, so you can either choose to have this or not, just because I didn't mention it in the question. It's good handling for these as well. Great. If I try a vector here, what will happen? So let me try this one. I'm going to, just as in the previous case, I'm going to have this vector here. I'm getting a warning message. Just because this condition runs only a single time, it says the condition has length of greater than 1. Yes, x has a length of 3, right? 3 arguments are given as x. it checks out the condition only for the first element. That is what this warning message gives you out. So if you want to write this particular function to a vector, it's important checking for couple of inputs, whether you are getting the desired value, right? So let's have the same thing here with -1 at the beginning, and we'll see what's happening. Invalid input. And thereafter, nothing is displayed. So just because this is invalid, it doesn't mean this one and this one are also invalid. It doesn't say something like that, right? Invalid input. So they have considered only the first argument to check this condition. So we have to handle that in a case of such a function. That is why we have to do multiple checks and see whether this is working properly, working accordingly, right? Comment it as a warning here. It's an unacceptable result, right? Because for this, yes, it should print invalid input. And for this, it should print 24. This, it would print 27, but it doesn't print anything else. So we have to handle for that. So how are we going to handle that? Modification to our purpose. Now our purpose is what? Getting values for all the elements of the vector. I won't give this for you to do alone, because it is a bit hard to do initially. It's not hard, but modification to our purpose. So I create another function called f3. Now I want to get rid of this warning. I want to get my desired result. So what I should do is, I have the same logic, but I have to run a loop. Just because this particular condition addresses only the first element of x, only the first element of the vector, I have to find a pathway which this condition is checked for all the elements of x. Did you get my point? Just because if condition checks only for length is equal to 1 types, that is, if x has just one value, it checks for that. But if x has more than one values, it checks only for the first element of x, but not for the rest. Then it is going to be problematic. I want to modify my function in a way that this condition checks every element of x. So for that, I have to repeat the same process. How many number of times? Number of times, and the size of x, a number of times, which is equal to the size of x. Size of x or the length of x. The command to get the number of elements of a vector is this one. Length of x. If x is 1, 2, 3, length is 3. If x is 0, 4, 1, 5, 0, 4, 1, 5, length is 4. Right? So likewise, this gives you the size of the vector. Why am I using a for loop? I want to check this condition for each and every element of x. Either it is 3 or 4 or 2 or anything, right? And this particular function is usable for a single element as well, because length of x is 1. So I goes from 1 to 1. So the first thing is you have to decide, you have to have a for loop here. For I in starting value. This is the index of the first element of X, right? Next value and next value, so on and so forth until it meets the length of X, length of this one, a vector. If it is a single number, doesn't matter. I goes from 1 to 1. So just a single iteration there. Doesn't matter. Within the for loop, so when you keep the cursor here, it highlights the closing bracket. Another feature in RStudio, so that you can make sure, okay, this open bracket is closed. Within the for loop, I have to have the same logic, but I have to address single element at a time, not just X greater than 0, because X is a vector. I have to see whether the first element of X is greater than 0 and do the particular function, whether the second element is greater than 0 and do it, whether the third element is greater than 0, do it likewise until it meets the entire length of X, length of the vector. I have to keep on checking this. I can't write if conditions multiple times. I just write it once, but loop it for number of times, for number of elements in X. I think that logic is understandable. Then what is this notation? I taught you that in the very first or the second lecture. Let's say R is a vector of 1, something like this. R is a vector. So when you print R, you are getting this. If you want to address the third element of R, what is the syntax? R square bracket, you put 3. So the third element of this vector is 5. So you print that one. What is the first element of this vector? That is basically 1. If I want to get the last element of this vector, 1, 2, 3, 4, 5, 6, I can give like this. That is 8. Or you can either give length of R. If you don't want to count like 1, 2, 3, 4, 5, 6 manually, if this is a huge sequence, then I can't keep on counting practically. So I put length of R to address the final element. Still, it gives you the same result. This is just the notation, the syntax. Okay, so I made use of this here. If condition, because this is a loop. So when I is equal to 1, if x1, that means the first element of X is greater than 0, it prints this one. So here also we had to put xi. X is a vector now, right? It loops. 2. If X has 2 or more than 2 elements, still it iterates, right? We check whether x2, the second element of X, is greater than 0. If yes, prints this. Otherwise, it loops. You can simply adopt the else condition also here. For the moment, I have only the if statement, right? So this function doesn't do anything if an invalid input is accommodated, right? Let's check the function. So I'm going to check these things. I run this function and check just for single element. Yeah, it happens, right? So when X is 4, the length of X is just 1, right? For I in 1 to 1. Okay, X1 is greater than 0. Is X1 greater than 0? Is 4 greater than 0? Yes. So it executes. Print 3 times the first element of X plus 18. Iterates. I is equal to 2. So length of X is 1. it does not iterate thereafter it exits from the function. For this one, let's see whether we are getting the proper result for a negative. We give a negative value and see whether this function is properly written. So it doesn't output anything. Just because we didn't handle an else statement, this condition fails. So it doesn't output anything. For 0, F3 0, nothing. Our intention now is getting an output for a vector of values. So let's see whether it's happening. Yes, I'm getting 21, 24, 27. I'm getting it vertically because this one prints and then iterates. Then this one prints and then iterates. That is why I'm getting this vertically. Anyhow, I'm displaying all the numbers. Earlier case, I got a horizontal array of values because it didn't print one by one. It printed everything together. In the previous one, this one, it printed everything together. There was no loop. Here we have a loop. So it prints the first one, iterates, it prints the second one, iterates, and it prints the third one, iterates, and thereafter, when I is equal to 4, it ends the loop and it ends the function. Okay, let's try this one. See, I have to have further modification for this. See, only when I'm checking this, I'm finding the issues or the mistakes or maybe improvements needed in this particular function. So if I run this, they disregard this one. Why? Because I haven't handled any else statement here. So without keeping a gap in between, it outputs the value when x is equal to 1. It outputs the value when x is equal to 3 as 21 and 27 respectively. But when x is equal to -2, it doesn't do anything. Even it doesn't keep a gap in between. So instead of this 24, there should be a gap. But it doesn't give out a gap because we have not handled anything. So we need further modification for this particular function if we want to get our thing done properly. If we want to, we have to handle all the cases to the best possibility. Okay, all the functions work, but there are problems when we change the data format, right? So we need further modification to our purpose, and that is simply handling an else statement. So I will copy this, right? So this is my new function. Same thing is written, same thing is copied. I have added only this part. After the if statement, open bracket, close bracket, I have opened a new block for else, print invalid x. You can print anything. If this is happening, this issue should be gone. We'll see. We'll run this one. If we give a single argument, doesn't matter. If we give again a single argument, earlier it didn't print anything for -1. Now it should print invalid x. For 0 also it should print invalid x. For this one, it prints all the results. And for this one, what should it print? 21, invalid x, and 27. Let's see whether we are getting it. Yes, 21, invalid x, 27. Earlier we got only 21 and 27. This is misleading. There are 3 inputs, only 2 outputs. We don't know for which output we have gotten this. So this is the best possible way of modifying a particular function to input a vector of values and output the value of the particular function. This is the best way out of the ones that we discussed. Someone is asking, if we give a single number, as the code says, does it take that number as an array? I don't have any yes and no answer for your question, but I can tell you something like this. If you give a single number, it is also an array of size 1. Does it make sense? Arrays have sizes.
Yes, ma'am.
Yes, you got it, right?
Yeah.
Yeah, okay. Arrays have sizes. Length of, so it's something like this. Let's have this is just a number. Okay. So if I print the length of this, usually we use this length statement to get the size of an array. It outputs 1. So it's the size of this. So when for loop goes 1 to 1 means it iterates only one time. Right. So we did the modification. Now we'll do a small exercise. So I'm going to give you a temperature, just a single value. Yes, just a single value for the moment, right? Forget about vectors. We will handle it later. Now you know how to accommodate vectors. Now I'm asking you to write a function to input just a single temperature value, which is in Fahrenheit, and convert it to Celsius. Don't display anything here, but return the value. So what is the difference between displaying and returning? Displaying means you are just printing. Returning means you are ending the function. You will nicely distinguish between the two when we construct complex stuff. At this stage, you will feel like it's the same thing. No, it is not. In some cases, print function does it for everything, every element in the vector, but return function returns after just one iteration. So things like that happens where returning means you're exiting, you're quitting the function, quitting out of the function. Printing means you're printing something, but you're still in the function. But if you don't have to do anything after printing some value, then of course you have to get exit from the function. So how do you return a value? Instead of print, write the name return here, right? Print invalid x, it's like return invalid x, something like that. Here you wrote print this one, or print x plus y. Here you wrote print thought. I'm asking you not to display, but to return. So what you have to write is return thought, something like that. So the task is this one. Convert a Fahrenheit value to a Celsius value. You have to input, just handle it for one number. For the moment, just handle it for one number. You don't have to accommodate vectors here. And return the value. So I'll give you the, do I have to give you the formula? Can you search and get how to convert Fahrenheit to Celsius? I'll give you, it's easy. I'll give you 2 minutes just because you have to search and see the formula for Fahrenheit Celsius conversion. I'll give you 3 minutes. Yeah. Yes, I got 2 correct answers. Three correct answers now. Yes, great. You all are approaching answers. Very good. So basically, this were in your answers. So I named it as temp F to C, Fahrenheit to Celsius. It's okay to give any name. A function, so T just for denoting temperature. Celsius, so I can give C or anything here, is assigned like this. So this is the formula to convert Fahrenheit to Celsius. You have to please put the brackets properly. Don't write things like this. T minus 32 times 5/9. Don't write things like this because this is incorrect. You have to multiply this entire thing by 5/9, right? So please use proper brackets, especially in a programming language. Even when you're writing it by hand, you don't ignore the bracket, right? So please put the brackets properly, and I ask you to return the value of this. So returning will exit the function. So we'll check for some known stuff. If it is Fahrenheit 32, we know it is 0 Celsius. We'll check with some known stuff so that we can see whether our function works properly. Fahrenheit 0 is Celsius negative 17.8, and negative 2 is something like this. So likewise, you can check. Okay, I got an interesting answer which I was going to discuss next. I'll simply copy and paste that and run that for you. And that answer has some problem, which I was going to say. So in the exam, if I ask you to write function to output just one value, don't write it for vectors. I know it is general, but it is additional thinking, additional waste of time. So be specific. It's okay. It's really good to think like that. And it's not incorrect either because that function works, right? I mean, doing more doesn't mean that you're getting more marks. Just stick to the purpose so that you can save time at the exam. But this one, I was going to discuss what is the issue here. So this person has handled it for a vector, which is a good thing, right? Does this really work? We'll see. We'll give a vector of values. So we'll have the same set of values as a vector 32, 0 and negative 2, right? And see whether this is working properly. Good that you did this because this was the next one in my R script to teach you all. Yes. So we are getting answers for this, this, and this. Okay, So if we be more specific, like if we are handling vectors, so this is working, right? Very good, this is working. If we want to handle a vector, so what he or she has done is adapted a for loop, 1 to length of the vector, return the values. Just because this is a for loop, it iterates this many times and it returns the values. Very good. If somebody does a code like this, right? Let me copy and paste the same thing. I just wanted to teach you the difference between the return statement and the print statement. That is why I had this small, simply doable code in a complex manner, right? So temperature, F to C modified. I'm going to input a temperature here, and I'm first going to define a vector. Before using, I have to define it. You can give a different name, doesn't matter. C for Celsius, designing an empty vector. So how do you define an empty vector? You give C and an empty bracket, right? Then I adapted the for loop from 1 to length of T, just because this is a vector. And I do my task here to have this code implemented. See, this one, I should define it before, otherwise I can't take it out, right? So we'll see what's happening if I run this code. So here I have commented this. Commenting means it's commented, it's neutral, it's not compiled, right? I have commented that line, it's just a line. Let's say I want to return C at once. Okay, return this value at once. What will happen? I run this code, I call this function and give the values. I'm getting the same thing. So return C out of the for loop. So this is the for loop, right? This return value, returning the temperature value, is out of the for loop. How can I get that out? I have to first define, I have to first tell the system, okay, C is going to be a vector. Without this statement, this function gives errors, because this return C, it's coming out, because they know about C only within the two brackets. Because we are not defining C prior to this particular block. So whatever the things that we write within two brackets, it is not in the global environment. That means it is not usable everywhere, right? Even within the function. You have, so before opening up the for loop, you have to define the empty vector where you are going to stack all these in case if you are using it after the for loop. For loop is starting here, ending here. You are returning all the values at once by this one. This particular code is equivalent to your code. This is way simpler, right? You don't have to do these things. You can simply run this code. I know, very good. But if we define this to be a vector and say, just like in your code, if I have this return statement within the for loop, right? So I'll uncomment this and comment this one. Just without having this out of the for loop, I had it in the for loop, just like in your case, right? Let's see what's happening. It gives out only the answer for the first one. This is why I said that this one, they are giving out this one. Why this is happening? If we give print here, same formula, if we give print, it is giving something like this because it first runs the for loop, right? Then it runs C1, C2 both. Then it runs C1, C2, C3, all the three, right? If you want to print one by one, you have to give Ci here, right? If that is the case, we are printing all the things one after the other, but we want to return it at once without getting it one after the other. If that is the case, we have to use the return other than print. Okay, so when we return this, here, right, what will happen is, it's unlike the print statement, it returns only the first one. Why? Because returning means you are getting out. You end the function there. So it doesn't loop any longer. Whenever this gets a value, when I is equal to 1, it gets C1. It gets a value for the array of cells here. It gets just one value because it's empty vector. We didn't predefine the size of the vector. It can be infinitely many longer, right? So they identify C as just a vector of 1, size 1, and they return it. That's what they do. If we use print here, we are getting everything. If we use return here, it pops out of the function. So that is the difference between print and return. When you print, you display it. When you return, you exit the function. So if you want to print everything at once, right, you have to store it in a vector rather than printing it one at a time. So whenever you are storing it at a vector, in a vector, you have to predefine the vector and then return it after it is stacked to that particular vector. So in all these iterations, what they do is they stack the values to the particular vector. When I is equal to 1, they put the value. When I is equal to 2, they put the value. I is equal to 3, they put the value. Likewise, let's say T is a vector of size 4. So C is also going to be a vector of size 4. We have 4 Fahrenheit values. We have to have 4 Celsius values, right? So here, what's happening is they keep on stacking. Okay, for corresponding T1, we are having C1. For corresponding T2, we are having C2. Likewise, and after stacking everything, we are returning the thing. Okay, so the return statement in that case should come after the for loop. Otherwise, it exits the function. After this statement, it comes out of the function. That is the basic functionality of this return statement. Okay, someone is asking a good question. If we want to get results as 36 Celsius with that capital C, how can we give the C in our formula? So if we want to, we anyway have to use the command paste, right? You can assign the value. There's a command called paste. You can make use of it to concatenate the output value with some string. So your capital C, Celsius, is going to be the string. You can search the syntax. Space 0, there are 2 things, right? So comma separatedly, you can give, you can check an example simply. You can even paste a statement. The value is this one. Something like that. So if that is the case, we'll try that. So then, of course, we have to, we have C here. We'll see whether this is working. Yeah, 0 Celsius, this one Celsius, this one Celsius. Right. If you want to get it here, I think this should work. We should go to something like that. Yes, you can either use this way. You can stack it to a vector like V and return it at once. Or if you want to print, still you can print this. Print V here, one by one. So this is the basic statement, paste. There's a statement called paste 0 also. You can search and see what is the difference. So if you want to output something with the unit, you can see unit as a string, you can use the command paste. Okay. So yeah, I'll keep it like this. Next one. Now I'm going to teach you how to use a function within a function, right? This is, let's say we want to convert from Fahrenheit to Kelvin. Yes, there should be a direct formula for that, but you are asked to use the previous function to do this. So that means within the function, you convert from Fahrenheit to Celsius and then Celsius to Kelvin. Let's say you don't have a, let's say you don't have a direct conversion from Fahrenheit to Kelvin. You have, but let's say you don't have. If that is the case, we are going to use a function within a function. You call it lexical scoping. You are making use of a user-defined function within another user-defined function, right? Just because I'm making use of this, I'll keep this one without the paste statement here. Okay. And you can round these off, like if you want it to 2 decimal places, you can make round, right? I'll teach you that as well here. This is the number, whatever the number that you give, this is the number of decimal places that you need. So it rounds off to 2 decimal places likewise. So if you want a rounded off answer here, you can make use of this command. This is an inbuilt function in the base package. So you can do things without accepting the original one that you're getting. You can round off. But at the exam, if you are not asked to round off things, don't round off. There's nothing wrong, but one thing is it is out of the question, and we are in trouble when giving you marks. But we can think and give. The other thing is it's, you are not going to manage your time properly if you do additional things. So be mindful on that. But when you're doing the report, when you're doing this in practice, try to add features and make this smoother rather than getting the raw output that you're getting. That is a very good practice. Okay, so now I want to convert Fahrenheit to Fahrenheit to Kelvin, but by making use of modified F to C function. Can you give a try? I want to convert from Fahrenheit to Kelvin and return the value of a vector of temperatures, right? A vector of temperatures. Make use of this function. So I'll give you around 6 minutes to quickly copy this function, because you are going to make use of it, right? You don't have to comment, just type this, or just to save time, look at this and type this. Make use of this function and convert from Fahrenheit to Kelvin. So the input value is going to be Fahrenheit, right? Within the function, it should convert to Celsius and again Kelvin. So within the function, how does it convert to Celsius? It's by using this function. So the algorithm that you have to write is from Celsius to Kelvin only. From Fahrenheit to Celsius, you are not writing this once again. You are making use of this function. I want to teach you lexical scoping. Use a function inside another function. That's what I want to teach you. I'll give you around 6 minutes. Try this. You can get the Kelvin formulation from this one. There. You have to add 273 or something. Celsius to Kelvin. So if you want to convert it to Kelvin, you have to take the Celsius value. You have to add 273. 0.15 is not needed. Add 273 and convert it to Kelvin. I'll show you this code just to copy and make use of this one within the function. Try it. I got some answers in the chat room. I got 2 answers in the chat room. They have not made use of the previous function 341 and 308. Your function may be working. I can see that you have adapted 2 for loops and done that. So what I asked you was to make use of this function. This is already done. That is why I gave you to copy and paste in this R script so that you can use it. You don't have to reconstruct this function body again and again. That is the purpose of a function. Why we created a function is because we can use it, right? There should be reusability. You don't have to do these conversions once again because it is done within this function. It's like within a function you are using the inbuilt function mean. It's something like this. So return they are all functions. You don't know how this is programmed in R. You don't know that. You know how this is working only. What this gives you out, that you know. But the body of this, you don't know. It's not visible to you, right? So just like think, okay, in R, there is a function to convert from Fahrenheit to Celsius. You don't know the inner algorithm of it. Let's say you don't know. There is a function called temp F to C modified in R. Let's say something like that. And you know the formula to convert from Celsius to Kelvin. But you are given Fahrenheit. Now you don't have any option. You have to convert it to Celsius and then convert it to Kelvin, because you don't know how to convert from Fahrenheit to Kelvin directly. Assume a scenario. You might know, but assume that you don't know. In that case, you are trying to get Celsius values from the Fahrenheit values that you have. So for that, you don't need to write a function again because it's already written. I want you to make use of it. Don't write the function, make use of it within the new function. Then you have Celsius values in hand. Then put to Celsius plus 273 formula to obtain Kelvin values. That was my question. So one student had done that. I think your, yes, it should be correct. Great. One student, 481, I think, just check whether the code is working. I think it's working. For a vector, see whether it's working. You have made use of this function within your function. So that is lexical scoping. 474. No, that is not the desired one. Your function, yes, wait. Yeah, your one is also correct. 474, yes, your one is also correct. Seemingly correct. I didn't check line by line, but the algorithm seems correct. So how should I do it? I want to write a function to convert Fahrenheit values to Kelvin. So F to K, let's say I want to have a function. Okay. And you are given a value, a vector of temperatures here. Now what you should do is, they're asking us to return, right? So we have to have a for loop just because we have to accommodate room for a vector of temperatures. So this T is vector. If you can write it like this, T vector, temperature vector, right? So you have a vector of temperatures here. So your for loop should run from the first value of this vector of Fahrenheit temperatures that you have, right? So I'll write F vector. You have Fahrenheit values, right? You have to convert it to Kelvin, but you don't know the direct conversion, right? That is the scenario. So you have this. You have to go from 1 to length of this vector. Okay. Here, what you have to do is converting from Fahrenheit to Celsius, but Fahrenheit to Kelvin. But you don't know to convert it from Fahrenheit to Kelvin. So what you do is you convert it to Celsius, right? So I'm going to have a vector of Celsius values. And I'm going to call this function. So here, what does this function do? Converting Fahrenheit to Celsius. So I have to give the Fahrenheit values here as the input. So when I give this one, this particular function goes here, do this, and return Celsius values. So here it returns Celsius values. So just because we have to go one by one, I have to put I here. Okay. And I have to predefine this one just because I want to store Celsius values in order to get the kelvins, right? Now this for loop will run and get all the Celsius values. Now I want to get values for Kelvin. So I want to store Kelvin values. Right? Yeah, you can either put this or not. So there are many ways of doing this. You can get the Celsius value, then get the Kelvin value, execute the loop. That is one way. Other way is you can stack all the Celsius value and directly convert it for Kelvin value. So we'll do both ways. If you want to one by one take Kelvin values, this is the way. You are going to store. If this is the way you are going to store from this one. So here you have vectors of Celsius values. And you are going to add 273 for each value. So when I is equal to 1, you are going to have the first Celsius value out of this function by using Fahrenheits. You are going to add 273 and get Kelvin, the first value. Then you are going to iterate. You are going to get the second Fahrenheit value. And by this function, you are going to get the second Celsius value, corresponding Celsius value. Then to that value, you are going to add 273 and store it in Kelvin vector 2. Likewise, for any number of Fahrenheit values given, you are going to compute Kelvin values, and finally you can return your Kelvin vector. This is the function. So let's see, let's say we have, this is the function. So I'm giving Fahrenheit values here. Let's say 0, 27. Things like this. I have 4 now, so this for loop should run 4 times. Let's see whether this is working. Error. Let me check. What is the issue? I haven't given the C sign here. Just because I'm giving a vector, I should give it as a C. It gives you out the values. So, you know, this is a very common one. Fahrenheit 32 means Celsius 0, Kelvin this. So these are the Kelvin values of these corresponding Fahrenheit values. Okay. There's another way. If you don't want to store these things, still you can do. So this is method 1. is another method. I just change the function. Here I'm not going to store the Kelvin values. I'm going to store only the Celsius values and then take that vector out, add 273 for each element of this Celsius vector and have the Kelvin vector and return it. This also gives the same result. So here what I did was I allocated additional computer memory to store Kelvin values and return them. Here I didn't store them at each and every level. I just assigned it and returned. I didn't employ a space like this for Kelvin vector. So depending on the situation, you can adapt any of these methods to meet the purpose. Doesn't matter, you can choose between and do the first thing, the simplest possible thing that you can do to achieve your result. So that is how you use a predefined function. It may be either user defined or inbuilt, doesn't matter, within another function. That is why we write functions. Let's say we have so many functions which we have to make use of all those in a single function, right? Then you're reducing your work and you have to write a very little number of lines, code lines in your new function to output some result when it comes to complex scenarios. So that is the importance of writing functions to do a specific task so that you can reuse them and make your code very legible, that is readable, very clear, clean, and understandable. If you have so many code lines, if you run pages and pages of code lines to do a particular function, nobody can understand it. It's very hard. It's so time consuming. So it's always advisable to build small functions and concatenate them all in one place where necessary. Then your code is very clear, easy to understand, easy to handle errors. When there's an error in one particular function, you can simply identify that and modify that particular function only, right? It's very easy for error handling. That is the use of writing functions. Other than that, we can write the entire algorithm in pages and get our thing done. So writing functions makes our life easy. Although thinking about the logic seems to be a bit mind-blowing, but we are not writing tough logics. We are writing very simple stuff here. Very simple in the sense logically convincing stuff, things like this at the basic level. So these should be practiced and try to understand the difference between printing and returning. When you're storing something, you have to predefine it, right? Either vector or a data frame or whatever it is. You have to predefine it if you allocate memory space. Can you see the two differences here and here? Be mindful about the brackets, because in case if this is, will this be a practical exam? Yeah, it would be a practical exam, but still you might have to write code lines You can use your computer, do the code and write it on the paper. That is the basic way. The papers are given so far. It might or might not change. I'll inform you prior to the exam, but it has a lot of time. So whenever you are asked to write the code by hand, don't miss out the brackets. Those are very silly things to do. Whenever you open a bracket, close it. Keep some space and close it. You can have some idea in head, okay, I'm going to write this many lines within this particular brackets. So that thing comes to your head with practice. You can type and practice things in the computer, but whenever you are asked to make it handwritten, don't do careless mistake. And can you see in our studio, they have automatically done some indentation to us. This whole loop is starting here, opening bracket is here, closing bracket is down there, under here. Even though you have a couple of spacing here, it doesn't give you errors, right? But when you have it like this, anybody can easily understand, okay, this is starting here, ending here. This function is starting here, ending here. It is going in line with the function name. So those are the good practices that you can adopt when you are writing things, even by using a software like this, or even when you are writing in the paper, on the paper. As much as possible, try to go with the proper and clear writing formatting of your program. So that is very readable, understandable, and you can easily capture your mistakes if you have done any. Okay. Yeah, so that is it for today. And I have uploaded an assignment for you. I know you all have exams in a couple of weeks, so that I gave you a very long duration for that. So you can download your assignment from here. So here you have a PDF file and a data set. So you have all the instructions are given in the PDF, but this is a very small task. You have to write a function and put a couple of outputs. So here in the PDF, it has given you all the guidelines. If you are good in programming, this is just a 5 minutes task. If you are moderate in programming, just a day is enough for you to think, and not to think, really, there's nothing big to think here. You have to be familiar with the syntax. Everything is taught for you. Just refer your notes. If you refer your notes and do these things, just one day is enough for this. But the deadline is, luckily or not, I just put it to be 31st December midnight. It is far away from today. You have approximately 45 days. I don't want to, compact you with your exams. I'm not going to give any more assignments before you finish off your exam. So leisurely get your exams done. This is the last assignment that I'm going to give you prior to your first semester exams. After that, I might give you one more assignment, one or maximum two. So this is going to be a very easy one. And here you have an Excel sheet. This is a data set. You can simply click on this and download it as it is. Don't change the name. Keep it as it is. This is a PDF file. Here you have to, the instructions are there. You can go according to the instructions. You have to do a function, very simple one. And you have to import this data set to your RStudio. So we did data importing from a text file .txt, but this, of course, you have to, if you want to import an Excel file, you have to install a package. So it depends on your RStudio version that you have. When you go here, sorry. when you go here, import dataset, so it says from Excel. When you download it, you just have to click on this and browse to your file. It will upload the necessary, install the necessary library and call the library for you. It will automatically do it for you. If you want to do it manually without using this menu driven option, you can go to packages, install XLS file, XLS package. Sorry, read Excel package. Read Excel, that is the package used to read an Excel file. So whenever you install that package, you have to call the library. So I gave you a very small read Excel. So it's coming here. You just install the dependencies also and click on install. So just because I have already installed it, I'm getting that thing. So after a little time, it will get installed. So after that, so if you want to install it manually, you have to write this code without going install and typing the name. Install.packages within brackets, you have to give double quote this package name. Once you install this, you have to call the library, right? That is library. Read Excel, and you have to run that. Okay. So you don't have to do anything. If you go to import dataset, read from Excel, you are getting everything here. When you can browse through where the dataset is stored and import it. So I gave you the first tip of importing the dataset to RStudio. So import it. It's not going to be a hard one. It's a very easy one. We did harder ones here, right? It's going to be a very easy one. Try to do it today, tomorrow, or day after, like very recently, because it's easy. You can do it even now. This assignment will be open at 4 p.m. today. So after 4 p.m., you can submit the assignment. You can download it even now. After 4 p.m. today until 31st December midnight, you can make your submissions. Okay. So that is it for today. I hope you got the lesson. I hope you have to keep on practicing with programming. This is not a hard one as long as you know the logic. As long as you know the syntax, there's nothing big to do. So practice these things. I'll upload the R script for you. Don't copy things. Just the question is there, given to you. Question is there, given to you. So take the question, paste it in your R script, and try to make your own function. And as a guideline, keep this R script. Don't try to study this R script. It's not going to work. You have to do trial and error. Okay, so that is it for today. Thank you so much for participating in today's lecture. Let's see you next week. Do the assignment. And thank you very much.
Thank you, madam.
Thank you, madam.
Thank you,
Okay.
madam.